Hey, I'm Luca, and welcome to my talk, Deno 1.0 is what has happened since. Who am I? I'm Luca Casonato. I'm 19 years old. I work full-time at the Deno company as a core contributor on the Deno project, and I help maintaining and building new functionality into Deno. Previously, I did web dev consultancy work on like a part-time basis, but I'm now full-time invested in open source. So I'm going to be talking about Deno today, but you might not even know what Deno is. So I'll give you a quick recap. Deno is a new server-side JavaScript and TypeScript runtime that builds on modern JavaScript language features like ES modules, promises, and async iterators. This is a lot different from Node. Node was built long before ES modules and promises, or even async iterators were a thing. Node uses a lot of other things like require and callbacks. Deno also sets itself apart by using web APIs where possible. So Deno aims to be like a browser, but in your command line. We don't want to invent many new APIs. We want to just use what the web has already come up with and what developers are already familiar with. An example of this is the Fetch API, for example. Fetch is the browser API to make outbound HTTP requests. In Node, you would have to require the HTTP module and learn a completely new way of making outbound HTTP requests. In Deno, you can just use the same knowledge you already have for building web apps. Another thing which is the same as in the browser is import resolution. In Node, you have to install your Node modules with npm. You npm install something, it goes into your Node modules folder, and then you require it using the require syntax. In Deno, you can just import files directly from URLs, just like you can in the browser. And Deno will handle caching the files and invalidating them when you want to re-download them later. Deno also has a bunch of built-in tooling. For example, we have a test runner, which you can use to do unit tests and integration tests of your projects. We have a formatter that you can use to format your code. We have a linter that you can use to find common mistakes in your JavaScript or TypeScript. And we even have the ability to compile your TypeScript code or JavaScript code to a single executable, which you can ship to customers or clients. So how did Deno come to be? Deno was introduced in 2018 by Ryan Dahl, the original creator of Node, in his talk, 10 Things I Regret About Node. What came up there often was the issues I've previously mentioned. So Node uses callbacks, it uses require, it doesn't use promises, it uses a lot of custom APIs because browser APIs for things just didn't exist back then. Ryan introduced a little bit of a demo of Deno back in 2018, which was written in Go. But we decided to move to Rust ultimately because Go is a garbage collector language, just like JavaScript. And having two garbage collectors in the same program, there's a good chance they're going to fight with each other and you're going to get very, very weird performance issues. Rust is the new modern systems level language designed by Mozilla, which has the same speed as C or C++, but with a magnitude of better safety features. To quickly give you an overview, I'm going to do a quick introduction demo. We're just going to write a quick TypeScript file, which just gets a URL from the command line, from a command line argument. It fetches that URL using the browser fetch API. We then get the server header from the response, and then we print the header value to the console. And we'll print it out magenta because everybody loves colors, right? I already have a VS Code window open here with a TypeScript file. So the first thing we're going to do is we're going to get the first command line argument. We do that by using the Deno global. The Deno global is the only global inside of the Deno execution environment, which isn't a web standard API. It contains all of the features which aren't part of the web. So things like getting command line arguments, or getting environment variables, reading from the file system, creating TCP sockets, things like that. So what we're going to do is we're going to get the URL for the first command line argument. You start counting at 0. So 0 is the first argument. We assign that to the variable URL, and we'll console log that. And now we can just run that, Deno run main.ts, and we'll pass https google.com as the URL. And you'll see it prints that out as expected. Next thing we'll do is we'll actually fetch that URL. To do that, we'll use the web fetch API, the one that's available in the browser already. So you'll see that takes an input, which is a string, which is a URL, or a request or a URL object, and it returns a promise of a response. Pass in the URL. Because it returns a promise, we have to await it, and we assign that to a variable called response. You can see we can use await at the top level. Deno's a modern runtime. It supports top-level await. It's a JavaScript feature which was introduced just a few years ago and has only been shipping in browsers since last year. We have this response now. We can call .headers, .get, and get the server header, just like we can in the web. And we'll assign that to a variable too. And let's also console log that out for now without any color, just so we can see what's going on. Let's run that. And we run into an error. This is completely expected. Deno has something called permissions, which I haven't mentioned yet. Permissions work just like in the browser. In the browser, when you open a web page, you don't expect the web page to have access to your file system or to have access to send you notifications or other privileged actions. Instead, the browser will prompt you if you want to allow a website to have access to certain privileged operations. Deno works the exact same. You have to tell Deno that you want to allow a certain script to do certain privileged abilities. For example, in this case, we want to allow network access. So we'll add the allow net flag. And now our fetch succeeds. We get the server response, or we get the response header server. We log that, and that logs GWS. Let's check that that's correct. If we go to Chrome and load google.com, look at the headers, the server is indeed GWS. We wanted to log that in Magenta, so let's do that. To do that, we'll import Magenta from the colors library in our standard library. I'll explain what the standard library is in a moment. So we'll import the latest version, and we'll want colors.ts. And let's actually open that real quick. So our standard library, these are Deno modules which are built by the core team, which are reviewed by the core team, and we make sure they work and they're high quality. This includes a whole bunch of functionality that in other ecosystems like Node, you would have to pull in through NPM. For example, you have a whole testing library which you can use, which has assertions, benchmarking utilities. We have tools to do hashing. We have tools to do UUID generation and validation. But in this case, we're interested in the colors module, and we can click on the documentation link here to view the documentation. And you can see this exports a bunch of functions. For example, the magenta function that we're going to use, set text color to magenta. So we're going to import that from this URL, and we do console log magenta, and we want to print out server with the server header. And let's run that again. And you can see we're printing out server GWS in magenta. So this is a 8-line TypeScript project. It would run exactly the same in the browser if it weren't for this Deno args, but you could replace that with a prompt, for example, or just turn this into a reusable function if you wanted to use this. So we released Deno 1.0 last year in May. That's a year ago from now, and we stabilized many built-in APIs. So Deno obviously has a bunch of web APIs, as I said previously, for example, the fetch API or web workers, which can be used to do parallel processing. So have multiple pieces of JavaScript execute at the same time. But we also have ways to access the file system or sub-processes or the OS, so environment variables, process arguments, or TCP and UDP sockets. These are all part of the Deno global. And you can see we have a documentation website, doc.denoland. And you can see here all of the Deno functions that are built in. We also ship with support for WebAssembly. WebAssembly is the new browser assembly language, which can be used to do super fast and a very reliably fast execution of code. And we also ship with TypeScript support out of the box, as I've shown you previously. So this file is written in TypeScript. And as you can see, I can write very TypeScript-specific things like as number. VS Code will highlight these, obviously, but also if I run them, Deno will not run this program because it doesn't type check. We also ship with a bunch of built-in tooling, like the formatter, the test runner, documentation generator, dependency viewer, a read eval print loop, the REPL, which allows you to small snippets or execute small snippets of JavaScript quickly, just like the Chrome DevTools, for example. And we also have eval, which allows you to execute snippets of JavaScript and TypeScript. So it's very useful for embedding into other programs. I'm going to demo the test runner real quick to show you what it looks like. I have this file here called main_test. Important part that is that it ends in _test. And in this function, I can call Deno.test. I can give it a name and a function, and I can assert something in here. So I'll assert that 1 + 1 is actually equal to 2. And if I test this, Deno.test, you'll see this passes. I can also change this. You see test now fails. So testing all built into the same executable. We released Deno 1.0, which added a new subcommand, DenoLint. It's a JavaScript linter that checks for common JavaScript, TypeScript problems that your code may have. For example, comparing a number with nan, which isn't valid. That's always null. I can show that in a second. It supports all of the recommended rules from ESLint. It's 100 times faster than ESLint. It also works on browser node projects. So it's like the tool in your pocket knife that you can use with like all of your JavaScript projects to easily find some common mistakes. We also added support for Deno eval p that lets you evaluate some JavaScript and TypeScript and print the result out to the console. But I'll demo this DenoLint thing real quick. So let's create a lint.ts. I will do something which is syntactically or which is not valid. 1 is equal to nan. This will always return false. I can DenoLint this. And as you see, it uses the isNan function to compare with nan. That's something that it found. We released 1.2 and 1.3 a few months later. That introduced more web APIs, namely the performance timing API, which you can use to do benchmarking, get very high precision timers. It's a web API, so it's compatible with the browser. We also added support for the file reader web API. That's an API that you can use to read files and blobs. We also added support for custom HTTP clients for fetch, allow you to do custom CA certificates, MTLS, which is something that you'll be very familiar with if you manage a Kubernetes cluster, for example. In September of last year, we introduced Deno 1.4. It added a lot more web APIs. It was a very large feature release for us. Namely, we added the WebSocket API. It allows you to do outbound WebSocket requests, just like in the browser. You can open a WebSocket to any server and then receive incoming messages, send out outgoing messages. We also added support for --watch, which is a flag that you can add to any Deno run command, which will tell Deno to automatically restart your program whenever any of the files or the dependencies of that program change. It's sort of like NodeMon, if you've used that for Node, but it's just built into Deno out of the box. Something else we added for Deno test was coverage support. So Deno has built-in coverage support. You can call Deno test --coverage, and it will give you a report of the coverage in your program. And you can see where you might still need to write some tests to get more coverage. Another lesser known web feature we added was CSS styling and console log. So in the browser, you can actually style your console log messages with CSS. You can change the colors, for example, background color, foreground color, strike through, underline. And in the browser, you can even change the font size or the font entirely. In Deno, we took from that the things that make sense in a server-side environment. So for example, foreground and background color styling, underlines or strike throughs, italics and bold. Those are all things that are supported. I can demo how that works real quick. So I'll open up the REPL, console log this, and you can see printing out hello world in red without any imports, just like I would in the browser. In Deno 1.5, we added a fast built-in bundler that's 15 times faster than TSC. It has built-in tree shaking. It outputs an ES module. It's incredibly fast. I'll also demo that real quick. So we have this main.ts file that we wrote, which imports this colors file. And let's look at how big that is. Colors, and you can see that file is like 520 lines long. It's Deno bundle main.ts. And you can see the entire outputted code starts here, ends right here. It's like 30 lines. It stripped out all the code that wasn't necessary. We also added support for alert, confirm, and prompt. Those are the prompting APIs that are available on the web. They allow you to request some input from the user, prompt them for some text, ask them a yes or no question, or just alert them of something. And we also improved our REPL quite a bit. So you've seen me use this as well. The REPL now has support for syntax highlighting. Strings are green, numbers are yellow. I can tab to autocomplete things. And we also have top-level await support, just like when you're running code. Deno 1.6, that was our last release of 2020. We added a huge new feature, which was Deno Compile. That was our most upvoted GitHub issue to that point. And it allows you to build self-contained standalone executables out of your Deno program. Deno already ships as just a single executable, which is statically linked. It just dynamically links to glibc. It's a single executable you download, and it just runs. And we extended that functionality to any Deno program now. So you can call Deno compile with some TypeScript URL or JavaScript or some local some file on the disk, and it will compile this into standalone binary. So we have this file server binary here now. You can see it's a binary, and I can execute this. Oh, give it a second. There we go. And I can now view this HTTP server at this URL. And you can see all the files are indeed there and are being served. We also added Deno LSP. That's our language server. For those of you who don't know what language servers are what IDEs and editors like VS Code, Vim, Emacs, or like the JetBrains IDEs use for language, used to figure out how to do code completion, what to show when you hover over a file. That's also directly integrated with Deno FMT and Deno lint, so you can enable format on save right in your editor. And we also have import completions for remote URLs, which is a pretty cool feature. So I can import Deno land, and as you can see, it's just auto-completing things from the web right now. Here, I want to download this S3 library at 0.40, and I want to import this file. And I just did all of that completely without ever leaving my editor. We also have support for Apple M1. We were the first server-side JavaScript runtime to add support for M1 in stable, and we've been shipping with that ever since Deno 1.6. Deno 1.7, we added cross-compilation support in Deno Compile, so you can actually Deno compile for architectures other than the one you're currently on. So you can compile for Linux when you're developing on a macOS machine, for example, or you can, when you're on Windows, you can compile your applications to macOS or Linux targets. We also added data URL support in imports and workers. That allows you to do dynamic code generation and allows bundlers to do very cool things as well. We added Deno Resolve DNS, which allows you to access the DNS APIs using the system DNS resolver or a custom name server. We added Markdown support in Deno FMT. We added permissions per web worker. That's actually a Deno specific feature. It's an extension to the web workers, which is a web standard. It allows you to specify different permissions for each web worker that you start up. So if you have some untrusted code and you want to run that in an isolated environment without giving it network access, for example, you can start up a web worker without any network access and talk to it via post message, via message passing. And for the server-side rendering community, we added global this.location and relative fetch, which allows you to do very cool things with isomorphic JavaScript. So JavaScript that runs both on the server and on the browser, is to give you some more portability between code that's written for the client and code that's written for the server. In Deno 1.8, we added another huge new feature, which is experimental web GPU support. So you might think, why would you want to have a GPU API on a server, right? Servers don't have displays to render things to, but GPUs are actually used for a lot more than just rendering. They're also used for machine learning, and machine learning is a tool which is a field where Python has currently dominated, and Setting up Python with a GPU is not that simple in many cases, and WebGPU gives you a very easy way to interface with a GPU in a way that's compatible with browsers. And we're hoping this will ship in stable by the end of this year, start of next year, when browsers also stabilize it. We also added support for web internationalization, which allows you to do relative time formatting. We revamped our Deno coverage support to allow you to output an LCOV format, which you can upload to coveralls. LCOV is the standard coverage format from ctools. It's the standard tool that everybody uses. We stabilized import maps. If you don't know what import maps are, I suggest you look them up on MDN. They're pretty cool. They allow you to rewrite import specifiers from one thing to another. So you could do import foo from example and have an import map that maps the example there to some URL. We also added Deno permissions that allows you to prompt users for permissions during runtime instead of having users give you all the permissions up front. We also added JSON support in Deno FMT. And as you can see, we keep adding features to Deno FMT, which are not just JavaScript and TypeScript. We want Deno FMT to be the ultimate only formatting tool you'll ever need for anything related to web development. In Deno 1.9, we added a native HTTP web server, which has support for HTTP 1.1 and HTTP 2 out of the box. It supports full duplex streaming. HTTP 3 is coming soon, where we reuse the web standard request and response objects. So it integrates well with the Fetch API or the Service Worker Cache API, which we're also introducing in the future. If you want to see the performance, check out Denoland/benchmarks. We're on par, if not better than Node in many scenarios. And we're always working to improve performance further. If you want to help on that front, feel free to join us on Discord or GitHub. Blob URLs was another feature we added. Blob URLs are something that exist in the browser to add media files dynamically into your website. In Deno, we added this for web compatibility. So if you have some code which creates blob URLs, that'll work between both the browser and Deno now. The latest release was Deno 1.10. We released that just last week with per test permissions in Deno test, which is another super cool feature. One of our contributors, Casper, contributed that. It allows you to specify different permissions for every Deno test invocation that can be used to check that your module only actually uses the permissions that you think it does, and it doesn't accidentally use something which you don't want it to. We can also run multiple test modules in parallel now, which can speed up testing immensely for large projects. We added watch support for Deno test. We added the web storage API, which allows you to do local storage, which is the same API as in the browser. It's persistent storage without the need for any file system permissions. It abstractly lets you store some key values persistently without having to have any permissions at all. So yeah, that's what we've done in the last year. It's a lot. And we're hoping to do a lot more in the future. We have 600 contributors now, of which we have very many active contributors as well. And we have hundreds of issues to solve and hundreds of feature requests to implement. And we have our work cut out for us. But I want to thank all these contributors, obviously, that have been helping next to the core team. And yeah, that's my talk on what has happened with Deno in the last year. I hope it was interesting. If you want to try it out, check out Denoland/manual/getting started. That will tell you how to download Deno and some examples for you to try out. If you have any questions or need help or want to contribute, check out discord.gg/Deno. And if you want to, contribute, also check out github.com/Denoland/Deno. That's our issue tracker and our source repository. And if you want to talk to me personally, hit me up on Twitter @lcastdev or at my email or on Discord. Thanks.